Hello guys, hello, Wade here bringing you the fourth lecture and lesson of prepping for the CCENT ICND 100-105. So what we're going to be talking about in this lecture and lesson is the OSI model. So I hope you guys are prepared for this one. It's going to be very interesting and you're going to have to pay a lot of attention here, guys, on this one. Um, this one's just, you be prepared. This is going to be very, if you don't grasp this, it's going to make everything a lot difficult throughout the course. Let me see. There we go. Hey guys. So we're going to be talking about the OSI model. This is going to keep the video short, but it can also, well, not too short, but basically to the point that this is a very important. You must really understand this and learn it and what it means, as questions will be focused around the OSI model, and you will be repeatedly using the OSI model to some extent and form. Engineers every day, network engineers, use the OSI model. Either they know it or not. It's what they use usually when they're troubleshooting, and some people live by it strictly. And there's a lot of, basically, to be a great network engineer, you really want to focus on the OSI model and know the differences between each layer, because it can save you a lot of time, especially out of the first three layers. So guys, let's jump into this. So you're going to see when we come up here, one of the best diagrams that I found, because it explains it so well, and it comes from Wikipedia, OSI model. And what I like, most of them you see, they do not have it in this PDUs and stuff like that here. Most of them only have it in a layer. Let's get a red pen. In a layer format only. In most cases, it is only in a layer format, the ones that I've seen. Just looking to see if I can undo, but it doesn't seem like I can. That's fine. So, okay. You want to start from the bottom up on the OSI model with 1. So, with this being said, you're going to want to learn basically all of the OSI model. But for network engineers, usually most of them on the physical network type stuff, you're going to be focusing on the bottom 3 the most. The 4th, you will learn a little bit, ACLs and so on from there. So you will have to know some of the 4th layer. The 5th, 6th, and 7th really don't have much to do as far as networking, but to understand it, it helps. Unless you're doing VMware related stuff, which is becoming more popular. Basically, 4 and below is where you really want to focus on it. The rest up there above, you just want to know the simple function, and that's it. So let me find it. So first one is the physical layer in the OSI model right here. The physical layer is basically your cable. I look at it as almost like physical. What physically connects stuff together. Basically, that the data travels through. If it's fiber optic, it's going through its cable. If it's Ethernet, it's going through its cable. So on from there. But now, don't think that somebody says a layer 1 that means the cable itself. It can be what it connects to. For example, it can connect to a router. Now, people call a router a layer 3. But now when they refer to a layer 1, it means that it's the cable even up to the connection of what it's connecting to. The interface could be down. That's still considered a layer 1 problem. If a interface is disabled, that's layer 1. There's no connectivity physically going through the cable. Basically here, the protocol data protocol data unit is a bit. Don't really have to know a ton there, but it doesn't hurt to remember that. It carry a long ways. The function, transmission, and reception of raw bit streams over a physical medium. I think that's almost a perfect way to put it. Um, Basically, it's allowing the communication and connection. Everything basically becomes bits and transmitted across the line in networking. So layer one is usually means a cable or physical transmission issue. Connection, maybe a cable isn't connected, maybe a port is disabled or physically shut down. It can be Ethernet card not being plugged in or getting power basically to a certain extent. Some people can refer to that as a layer one. Um, Basically, it's when your cable isn't getting any kind of signal. So just because it's layer one, it can be the seating of a PC card, of an Ethernet card, has gotten loose and not having power also. And we have Ethernet card also sits on these two layers. Actually, it can be, yeah, most people say that the data link layer is what the Ethernet card mostly does, but you always hear one and two. I've always heard of one and two as the NIC works between both of them layers. Data links are units in frames or frame, and it is the reliable transmission of data frames between two nodes connected by the physical layer. So you already see that they're working off of each other. So layer 2. Um, the good way to see layer 2 in most networking terms, or to be able to distinctly tell them apart, is when you read this, it becomes a little bit more um, jumbled. Do remember that it travels, a data link is frames. It is frames. But most of the time, layer 2 is what they call, usually most people are referencing to a switch. It can be the network card, but a reference to a switch. In most cases, there can be layer 3 switches, but we'll go into that. But the reason they call this layer 2 is because of MAC addresses. So as you hear of MAC addresses throughout the course or throughout these videos, I want you to think of that as a layer 2 in the OSI model every time. That is a layer 2. It does not see the MAC address. It's not seeing this. It doesn't recognize it because of the MAC address. That is all layer 2. A MAC address isn't being picked up. It's a switch issue. Switch operates off of MAC addresses, so can be layer 2. Doesn't mean that the switch still can't have a layer 1 issue, but usually when you hear a layer 2 device, it's the max of what that device works at. Switch works at layer 1 and 2, so that's the way it basically operates. It's mostly through MAC address table, which you'll learn later on. So switches are highly referred to as layer 2. Like I said, layer 1 problems still can exist. It can be a port does not work on the switch, or it falsely thinks it's working, it's not getting power or something to that extent. Layer 1 still can exist between routers, switches, and even the network card in PCs. So the next one is a layer 3, which is called the network layer. It travels or uses protocol data unit packets. It's an ugly, ugly circle. And packets, or the function of network, is structuring and managing of multiple node network, including addressing, routing, and traffic control. Now, when it says addressing, it should be a specific address here. At least that's how I want you guys to think about it. Because technically layer 2 can be considered addressing a MAC address. But layer 3, as you know, is an IP address, which people are more familiar with. Most people learn about IP addresses before they ever learn about MAC addresses. An IP address is something that, and the reason why is pretty much you have to have an IP address to get to the internet. So if you're watching these videos, you're watching YouTube, you're using an IP address to access the internet, to access the network nowadays. For that extent, most home networks, you're going to have an IP address. Most everything nowadays is going to be assigned an IP address in some form or fashion. Basically, the switch itself cannot operate to get you to the internet um, at all. So most everything's going to have a layer 3 IP address also from there. Basically, if you take a switch and you connect it to your internet service provider, um, you're going to have usually a lot of issues. Most people use what they call like a router or a wireless router, which is a multi-port router, which is kind of like a switch slash router, and that is normal for home networks. It's kind of a combination where and networks for enterprises or companies, you're going to have two separate. You're going to have a switch, and then you're going to have a router. Switch is basically to support the end users, and the router is to control the traffic and how it's presented across the WAN usually, or and it helps basically assign. Well, it doesn't technically assign. It can actually assign IP addresses if you set it up to, but it routes and controls information through IP addresses. Now, does it still deal with the MAC address? It does. So don't think that it's completely gone. You will learn that MAC addresses still have effect all the way through. Just because you go up a layer, it does not drop the lower layers at all. So I want you to understand that. That is what you need to really understand about the OSI model. The higher up you go, layers below are still there. So that's why it's very important to understand the OSI model, to a certain extent, so you can identify these layers and know how far up it goes. For example, if you're having a network issue, the first thing you'd really want to realize if you're having trouble communicating, is it a layer 2 issue or a layer 3 issue, depending on where you're trying to communicate to or with. And a lot of times people use ping as a quick tool to know if they see something, if they can connect to something. And you will be very familiar with ping and traceroute by the end of these videos and when you get ready to take your ICND1. So the fourth layer, which is, these are the four, like I said, you really want to learn. You don't have to learn a ton about the fourth layer. You just need to know that protocols, TCP, UDP operate at this transport layer. And I consider like the transport layer to be a little bit of both sides. The application side is I call 5, 6, and 7 usually application side, but you do need to understand how they work. But the transport layer to me is like a bridge between these two. And so both sides have to learn about basically software and networking side both have to share this transport layer a little bit and understand what it works, because it really puts them all together. It's the bridge between them, in my opinion. You won't have to basically know it as that, but that's how I view it. So it means you need to know a little bit about it, or at least the networking part of it. And this really here is the networking part of it. Is TCP, UDP. You're going to learn ports. You're going to need to know the ports. And in within the next few videos, you're going to see ports on a sheet, and there will be ports that I would want you to remember going into your ICND1 exam. So TCP, UDP, transport layer. You need to know that TCP is considered a reliable connection. It basically authenticates, or we'll say authenticates or agrees with the other end. It looks for that communication. They agree. They talk to each other. It sends. It acknowledges. They use what they call a handshake, which we will talk more about in more detail in TCP and UDP. But they use a three-way handshake is what the reference is to TCP. UDP is a lot different. UDP, if you've been in a Skype call, it uses UDP. UDP is a send. It's not made to be reliable. Now, the application can make UDP to a certain extent reliable, but every TCP application is going to be reliable. UDP is going to be optional on the application itself. But UDP, a good example is Skype call. If you've ever been in a Skype call, someone starts sounding like a robot or they start breaking up, that stuff doesn't get just corrected and sent. It stays that way. You really don't understand them. So what you do, you ask, hey, you broke up. What did you say? And then from there, they will tell you again. That's a form of UDP. But if it was TCP, even though you won't find voice protocol or voice related stuff TCP, and there's a good reason why. If it was TCP, it basically, you would have heard everything. It just would have paused or something to that extent, or controlled the traffic, but it all would have been put back together, almost like a recording. Um, if somebody made a recording and they were very plain and nothing went wrong, you can always go back and play it, or it's very clear and they know it works. Where UDP, it's on demand. At that point, it's unreliable. So things can get crazy sometimes with UDP. But now, just because something uses UDP doesn't mean that it can't be somewhat reliable. It's the application can request in some way or form to make it reliable, but the protocol itself is not reliable. It's a send, doesn't require an acknowledgement. So if it's UDP, you just need to know it as a basically uh, non-reliable kind of protocol, where TCP is a reliable three-way handshake protocol, and they control the traffic, how it's sent, to ensure that each piece has been received. Um, and if it hasn't, it will request it again, or UDP will not request it again unless the application, which is the upper layers, make that happen. But we're only looking at the transport. That's all they want you to focus on. In the ICND1, you don't have to know that about UDP. All you need to know is that it is a connectionless oriented, basically transport unit or protocol unit. So let's go over here. Let's see. I'm going back over here. There we go. Trying to find where my mouse is, if I can find it. There we go. Alright, so reliable transmission. I'm going to circle this, then I'm going to read it actually this time. Reliable transmission of data segments, that's TCP, reliable, between ports on a network, including segmentation, acknowledgement, and multiplexing. So this can be a little bit, make it favor more of TCP. It doesn't mention as much about UDP being connectionless, even though there's a few things kind of mentioned there. But like I said, the main thing you need to know is at the transport layer, you do got TCP and UDP. Now, when you hear those, they sound, oh, that's simple. That's two things. But to be honest, that operates a lot of protocols, or a lot of ports you're going to understand. So all your ports are going to be based on transport layer. TCP and UDP is two categories for ports. One's connection based with a three-way handshake. The other one is basically a send, keep sending kind of connection, which is UDP. So the next three up here, 5, 6, and 7, is the host layer, or the very top layer of this. Do you need to know them? Yes, you do. Will you use a lot of them or see a lot on it? No, you won't. So we got session. Of course, the protocol and data unit is data, obviously. Session is managing communication sessions, continuous exchange of information in a form of multiple back and forth transmissions between two nodes. That's a session. A session is exactly establishing a session. This should be somewhat familiar term to some people, and it kind of means that to a certain extent, or it pretty much does mean that about head on. You just need to understand what it means on the not networking side, but the PC side slash IT side. It's in the OSI model. It does, all these layers depend on each other. Like I said, these work down. So if you ever work with somebody and somebody at the top layers is saying, oh, it's a network problem, this OSI model will help pass it off. And they should know it also, as a software developer or whatever they're planning to do. So we got 6 here, which is presentation layer. Of course, it's data also. We're going to go ahead and circle it, and then we're going to go over it. So it is the translation of data between a networking service and an application, including character coding, or encoding, data compression, and encryption/decryption. So the translation of data between a networking service and an application, including character coding, data compression, and encryption and decryption. I'll be honest, I don't know if you have to know that as much as what it physically goes to, as far as that function here. Alright, so the last layer, the application layer. And it says high-level APIs including resource sharing and remote file access. That's kind of not very detailed. So if you're going through these videos, I recommend just looking up a few, what they list, the session and presentation and application layer. Just get familiar with kind of what to expect on those, as you might see a little bit of something on it, but it's not going to be major. If you don't know the top three, it really won't hurt you. You still can pass the ICND1 easily. I'm going to be honest, I don't think there's any questions that's going to reflect on these three. I haven't heard of many people talking about them. All you need to know is basically these three right here are grouped usually together. You will have to know 4, 3, 2, and 1, which is the transport layer, network layer, and data link layer. And you do need to know that these flow down when being sent out. And whenever it's being received, it flows down to up, which should make sense. Physical layer, so it's coming up off the line. The easiest way to remember this is that it's going out of the PC or out of the server or whatever you want to call it. It's going out of it, so it's going to flow down. Then it's going to hit the line. Remember, the physical layer is the line or cable. We can consider this the cable. This was layer 1. And then when we're coming out of the line into the next machine or whatever the destination is, it's going to read it like this. And basically that is, we're going to just say coming in. I would put receiving, but I'm probably not going to be able to fit that in my terrible mouse writing. So going out, it goes from top to bottom, 7 through 1, and then when it's received on the other end, it goes all the way up to 1 to 7. And that's only host ends. Could be PC to PC, PC to a server, or etc. from there. And it should be kind of a simple concept. Physical, if you understand how it works, this is going to be super simple. You ain't even going to have to think about it this way. But I just want you guys to understand. So this physical cable, it has to be the one to travel across the physical cable. And then whenever you're receiving it off the physical cable. So you're going to start at the physical layer with it receiving in. When you're sending out, it's going to end on the physical layer. So this should be kind of a common concept. I don't know how much easier to explain that, but sending out goes from 7 to 1. Coming in, it goes from 1 to 7. If you're unsure, think about it from a cable perspective. Aspect 1, the physical layer is the cable. So when you're sending something out, you have to go to the cable. Think about it as you're getting ready, you're processing, you're getting up, you're processing, you're getting ready to go to work. The physical is the road. So you're going to work, and when you get to work, what are you doing? You're coming off the physical, you're going up into your job and so on from there. So think of it as a road, as a cable. Basically, it is where the traffic goes from one destination to the other off that media. That is the physical layer. And if you think of that concept, you really can't go wrong as far as knowing how it breaks it down, sending it out or coming in. As you will not, as far as I know, you really won't have to know it um, like this as far as the ICND1, but it does help to understand this even for troubleshooting um, for the OSI model. So guys, that is the OSI model. If you need to find this online, uh, really understand it, you're going to need to know the OSI model, guys. If you don't, you're going to be in a world of trouble when it comes to troubleshooting devices and etc. from there, and even as far as understanding how these switches and routers work and how to troubleshoot where your problem lies, if it's in a switch, if it's in a router, if it's in the cable, and so on from there. So find your OSI model. You can find plenty out there online. Look at them. Spend a good day really understanding the OSI model. The better you understand it, like I said, the better your troubleshooting skills will be. As far as that, if anyone who watches the video, if you got any tricks to the OSI model, let people know. You will even have to memorize how this is in order. Um, Physical, data link, network, transport, session, application. A lot of classes, if you go to a university or if you go to a technical college and you're doing networking, they are going to make you memorize the OSI model. So you should be able to write it down from top to bottom and memorize it from there. For networking purposes, you really need to know the bottom four. So read them inside and out. If you want to, do a little bit of research on them. Just understand the TCP, UDP on the transport, network layer. Like I said, IP address, data link layer references more towards the MAC address for troubleshooting. Physical layer is the cable itself or a connection end going to the device. Not actually entering into the device yet, but basically the physical cable that touches the device. So whatever that physical cable touches, basically. And when I say that, I mean when it touches the switch, it can be the interface of that switch, but it can't be anything else past that, or the won't call it NIC, the port. If the port is completely failed, it can be considered a layer 1 issue. So, right, guys, that does it. Really focus on this OSI model. Like I said, things are going to be a little bit tougher now. We're not talking about devices. We're not talking about, well, we're talking about devices, but it's not the simple, hey, this is something that you probably might have seen or known before, even if you didn't know a lot about networking. Now, if you've never really worked in it or took any classes in it, some of this stuff should now start feeling really different, and you're going to learn a lot more rapidly. Now, I took my ICND1 within a month's time of studying and learning myself now. So, guys, if you watch this, I promise you, if you watch, you pay attention, once all these videos are up, you can do this within probably a month's time. It's not unheard of, but you really need to focus on the important parts, and this is one of them. Spend time on this till you completely understand it. Definitely the bottom four. I can't stress it enough. Anyways, guys, that does it for this video for the OSI model for networking. Until next time, guys, I hope you enjoyed the video. If you enjoyed what you've seen, please subscribe to my YouTube channel, and you can put on the notifications if you're watching a video as they get posted. And I hope everyone has enjoyed the video. Until next time, see you guys in the next video.